misery. Alright, welcome to the electronics training.
I wrote down what's strong.
Today's goals are to learn about the operator interface, how the robot communicates, and the robot system. First, basic electrical theory, Ohm's law, which consists of voltage, current, and resistance. Voltage equals current times resistance. It sounds really familiar.
This looks a little familiar.
Power, which is measured in watts, is equal to volts times resistance, or times current. This is not stuff you guys will remember, or will memorize. These are sim motors at the top. In the 12-volt system, the current max power. Why do I care about power, resistance, and current? So the robot will use the right fuses, the right wires, be powerful, and won't blow a fuse, and won't catch on fire. Because if you use the wrong size wire with too much power going through it, it's going to catch on fire. Basic types: solid or single-stranded wire, or stranded, multiple smaller wires twisted together, or jacketed, multiple insulated wires with an outer cover, which is like Ethernet cable. The size or diameter of a wire is referred to as the gauge of the wire. The smaller the gauge, the larger in diameter the wire. The larger the wire, the lower the resistance per foot. The larger the wire, the more current it can handle. Undersize produces excess heat. So again, if you use too small of a wire for the power you're trying to put through the wire, it'll catch on fire. AWG stands for American Wire Gauge. And this is just a chart that tells you for the power that you're trying to connect, what size wire to use. Typical rules for FIRST robotics for connecting the battery to the power distribution board. Use 6-gauge red and black wire or larger. 12 or larger must be used for all circuits protected by a 40-amp circuit. 14 or larger diameter for a 30-amp circuit. 18 for 20. 20 for the power connection between the power distribution board and the C-RIO. 20 for connection between the power distribution board and the bridge, which the bridge is what communicates to the driver station. Circuit types: power, large power current to drive motors, sensors and actuators, low power signals for sense and control, the digital signal, which to connect like the digital signal is the Jaguar. Connect that to the digital sidecar, and it sends the signal telling tells the Jaguars when to turn the motors. That's a three different wires, and one is a positive, one is a negative, one is a signal. Electrified. Operator interface. Hardware is the laptop, joysticks, and optional is like custom controls, like either last year or the year before, they gave us the option to use the Xbox Kinect to control our robot, which we did not do. Software is the dashboard. And there's the joysticks. Switches and potentiometers can be used to build custom interfaces for a giant controller. The components of the robot: power system, a battery and or compressor, actuators, which are the motors, the servos, relays, robot signal light, and pistons. Sensors are potentiometers, encoders, vision, and gyros. Controllers are the Stereo, digital sidecar, speed controllers, and spikes. And then networking is the router and the bridge. And then when we're wiring the robot, this is a diagram that you can find on the team website that we will constantly be referring back to make sure we accurately wire the robot, because that is something that they go over very closely at the competition, making sure that you have everything wired correctly.
That's a good question.
And just more diagrams on how to wire stuff. And this right here is a picture of the power distribution board, which everything that gets power goes through that. And it obviously gets power from the battery. The robot brain is the Stereo, which are extremely expensive. They're like $1,500.
Well, the smaller one we bought was $700.
Yeah, not cheap. And so if you wire that wrong, imagine just blowing that up, you just lose $700. Compact Stereo has 4 slots, less inputs and outputs. Advantage is smaller and lighter, so you can make the area on the robot where you're doing all the wiring in a smaller, more confined space. No, I'm just pushing the down button, just going back. So red is positive, black is negative, and white is signal, white or brown. So the digital sidecar, this is what I was talking about, like the 3-wire, the PWM cables connect to, and they have to go on there a certain way. When we're wiring the robot, you'll notice that, like, if you plug it in backwards, then it won't work. That's because the signal wire is on one side, so it'll never get sent the signal to turn on and off. LED should always be green when the robot is turned on. There's 10 different outputs, so you can connect it. 10 different motors, servos, jaguars. Power connection to the 12-volt output on the power distribution board is there. Then the robot signal light gets wired through the digital sidecar. Must connect probably should have looked at this. Motor speed controls, loud motor controllers, Jaguar motor controllers, you can use those, or we don't use the Victors.
No, there's a new one called.
Spike.
No, that's like, there's a new motor controller that's better than the Jaguar. We got it on last year for about little ones. So this is outdated.
Yeah, this one's a couple years. So that's what a Jaguar looks like. Those go bad very easily. So on one side of it, you connect the positive and negative for the motor, and then the other side the positive and negative for the battery, or from the power distribution board. And another thing is when because how you connect the wire to it is you unscrew the screw, and just screw down the wire. When you're crimping on the connectors onto the wires, you've got to make sure like you crimp it down all the way, and don't try and use the wrong tool. That's a spike. That just sends like a pulse of electricity to turn something on, or turn something one way or another, turn something on or off. There's robot signal light, which looks like that. It's a limit switch, so you can have it to where like if something goes up and once it touches that, it won't move anymore. Sensors. Slide is 50. Okay, that's it. That's all the slides. Safety. Yep. Do you want me to do the safety? Electrical tools. Are those all in the other?
What you can do is take the t-shirt pod out, show them the stuff on the t-shirt pod, and show them the slides.